Hi everyone, Chris Kuzmal here. We're now going to work on getting into 3 dimensions in terms of our display. So if we look at our n-body code uh, for a matter object, then we are interested in what happens when we draw it. And when we draw our objects, we use stdraw dot circle, and we do my x position divided by 100 and zero point 0.5 and 0.01. The 0.5 is the y position, which means that we're ignoring the y position right now when we draw our objects. And the 0.01 is the size of the circle, the diameter, I think. Maybe it's the radius. So let's change this 0.5 into my y position divided by 100. And it seems to be happy with that. And let's just go ahead and run our code because it looks like our code is set up already to display the graphics. And let's just see whether or not our animation, we passed 10 out of 10 tests. When we do the animation, we know, well, no, we do see, oh, it goes flying up. What an interesting result. Our objects fly up the screen, the Y coordinate goes flying up. That seems like it might be wrong, okay? It might be right, it might be wrong. We need to investigate. And so to investigate, what we're going to do is we're going to find out what's going on when we do our n-body loop, okay? And so our n-body loop is here. It establishes our objects at locations 10, 0, 0, 0, because the default is 0, 0, and 20, 0. Okay, so that doesn't tell me anything about the y velocity. We give our objects names, we give a couple of them colors, we collect them together, we enable double buffering for our objects, then we compute the forces, we update everything, and we update the graph. Okay, well, I've got good news and bad news. The good news is, well, there's nothing that looks wrong here. The bad news is there's nothing that looks wrong here. We can't find it. We probably don't have enough unit testing because there shouldn't be, we're not expecting any y velocity at all. And so somewhere in there, some y velocities getting created. And so I can attack the problem by exploring my code. And I'm going to do that right now. But if I don't find any solution, then I'm going to do more unit testing in order to specifically identify whether my velocity and my positions are good. All I've done now for my unit testing basically is to check to see if the acceleration is right. And I've assumed the acceleration updates have all been good. So let's look at a matter object and see what happens, because although I think the unit testing would probably find our problem, I'm intrigued. And so the first question is, do I have a initial value? And look, I have an x force of 1 and an initial y force of 1. Or what are these initial forces doing at 1? Okay, those forces shouldn't be 1. So let's go ahead and set those forces to 0. And it'll be interesting to see whether or not that produces any errors as perceived by our test code, right? So will our, oops, so I'm gonna set those forces to 0 because the default value for our forces should be 0. If we run our code again, I've got good news and bad news again. Now the bad news is our objects don't seem to be displaying. The good news is they don't seem to be flying past like in some y direction. Our y position is going to be 0, and so that tells me that the location is not quite going to be where we want. So let's make our y position 0.5 as an initial. Oops, 0.6, 0.5. And let's not do that there. Let's make it so that we initialize that in the loop itself, okay? Because that really is where it makes more sense. When we initialize these objects, rather than having a location, an x location of 10, let's have 10 and a y location of 0. Let's have everything be at a location 10. So 10, 10, 0, 10, 20, 10, and see how that runs. Still no luck. So we'll have to address this in the next video.